oxidizing agents and reducing agents. We're going to learn what they are, what they do, and how to identify them in chemical equations. So if we're talking about oxidizing agents and reducing agents, let's just refresh our memory about what oxidizing and reducing are, okay? So oxidation is a loss of electrons, and reduction is a gain of electrons. I got a diagram here, and we've got two things, A and B. Maybe they're atoms, maybe they're compounds, and there are electrons moving from A to B. Okay, so A here is losing electrons, which means that A is being oxidized. B over here, B is gaining electrons, which means that B is being reduced. Okay, so that's oxidation and reduction. But here we're talking about agents, oxidizing and reducing agents. So what's an agent? Well, the word has a bunch of different meanings, but in this situation, an agent makes something happen. Okay, think of like the agent for a movie star, right? They help the actor get jobs, they help the actor get into movies. An agent makes things happen for that movie star, okay? And that's exactly what oxidizing and reducing agents do. They make stuff happen. An oxidizing agent makes oxidation happen. And a reducing agent makes reduction happen. Okay, so let's talk about the things that something would have to do to make oxidation happen, to make reduction happen. Let's start here with oxidation. What does something have to do to make oxidation happen? Well, take a look at this diagram. Here we have A, it's being oxidized, it's losing these electrons. But it's really important to remember that atoms can't just throw away electrons. They can't just chuck them into space. An atom can only get rid of electrons if something else is going to take those electrons away. They have to give the electrons to something else. Okay, so we can say that in order to make oxidation happen, something else has to take the electrons away from the thing that's being oxidized. So let's look at what's going on here to allow oxidation to happen. Okay, A is trying to get rid of these electrons, and B takes them. Okay, so B takes the electrons from A, oxidizing it. It's making oxidation happen by taking those electrons away. And we've said that an oxidation agent, an oxidizing agent, makes oxidation happen. So B is the oxidizing agent. It makes oxidation happen by taking the electrons from A so that A can get rid of them and so that A can lose them. Okay? So that's what the oxidizing agent does. Now let's talk about reduction. Here in our diagram we have B. B is gaining electrons, but you just can't gain electrons out of thin air. If you're going to gain electrons, something else has to give you those electrons so that you can gain them. So we can say that to make reduction happen, something has to give electrons. Where are the electrons coming from that B is gaining? Well, they're coming from A, right? A over here gives electrons to B, reducing it, allowing it to be reduced. And since A is making this happen by giving the electrons to B, we can say that A is the reducing agent, okay? So B is the oxidizing agent. It's making oxidation happening by taking the electrons from A. A is the reducing agent. It's making reduction happen by giving the electrons to B. Okay, so we got reducing agent and oxidizing agent. And if you look at what's going on here, there's kind of a switch that takes place. Okay, the thing that is oxidized, the thing that loses electrons, is the reducing agent. And the thing that is reduced, that gains electrons, is the oxidizing agent. Okay, the thing that's oxidized is the reducing agent.
नया कैडबरी मोरो पावर का पंच।
छोटे कारोबार को आगे बढ़ाएं पिज़्ज़ा के साथ।
oxidizing agent. Okay, so this is one way to remember that we get this kind of flip-flop. But I think a better way to keep it in mind is remembering that the oxidizing agent makes oxidation happen by taking electrons away. Reducing agent makes reduction happen by giving electrons. Okay, so this is an overall view of what oxidizing agents and reducing agents are. Now I want to look at two chemical equations where we'll figure out what elements and compounds are the oxidizing agents and the reducing agents. So here I've got this chemical equation. We want to figure out which of these elements is an oxidizing agent, which of them is a reducing agent. In order to figure that out, we've got to know how oxidation and reduction are happening in this equation. We have to look at how electrons are being transferred. And to do that, we got to look at the oxidation numbers of each one of these elements. So I have a whole bunch of videos on how to write oxidation numbers. I'm not going to show you how to do that here, but there are a bunch of rules that you follow. You go through these rules and you're able to write oxidation numbers for all the elements in a chemical equation. And these numbers show how electrons are moving. Okay? So to figure out if oxidation or reduction is taking place, we look at the changes in these oxidation numbers. If the oxidation number goes up, oxidation is taking place. If the oxidation number goes down, reduction is taking place. Okay, we'll start off by looking at calcium here, Ca. Ca starts off as 0 on this side of the equation, and then over here, it's +2. Okay, so calcium's oxidation number is going up, which means that it is being oxidized. Okay, so calcium here is oxidized from 0 to +2, which means that it loses electrons. Then on the other hand, we have Cl2, chlorine here. Chlorine is 0 here, but it's -1 on this side of the equation. So its oxidation number is going down, which means that it is being reduced. It is gaining. It is gaining electrons. Okay, so that's what's happening with movement of electrons in this reaction here. And we can kind of sum it up with a simple little diagram like this. Okay, that electrons are being transferred from calcium to chlorine. Now, we know it's being oxidized, we know it's being reduced. Let's figure out what is the reducing agent and what is the oxidizing agent. Okay, so calcium here is losing electrons. It is giving electrons to chlorine, but by doing that, it is allowing chlorine to become reduced. It is allowing chlorine to gain electrons. So calcium is the reducing agent, because what is oxidized, the thing that is oxidized, is the reducing agent. And then over here, chlorine is being reduced. It gains electrons, but by doing that, it's taking electrons away from calcium, which is allowing calcium to lose those electrons. It's allowing calcium to become oxidized. So chlorine here is the oxidizing agent. And we can also keep this in mind, that the thing that is reduced, chlorine is reduced, is the oxidizing agent. Okay? So that's how we figure out what the reducing agents and the oxidizing agents are in an equation like this. We start with the oxidation numbers, we figure out what's getting oxidized, what's getting reduced, and then we can apply these rules, or we can just think about it. What is helping the other get oxidized or get reduced? Okay, I want to do one more equation now that's a little bit more challenging than this. So even if this one makes total sense, you might just want to stick around and watch one more. It could help you out. Okay, this equation here is a little bit more complex than the one that we just looked at for a couple of reasons. First, it has a bunch of different elements. The other equation only had 2 elements. And the other thing here is the elements are grouped together in compounds. So there is more than one element together in these things that we start off with. Okay, those are going to change a little bit the way we apply these rules. Here's how we're going to do it. The first thing we want to do is we want to get oxidation numbers for all the elements. Again, I'm not going to talk about that now, but you can watch my videos on oxidation numbers if you want to do this. But we follow these rules for oxidation numbers, and these are the numbers that we're going to get. So now we want to look at the changes in oxidation number for each one of the elements. We got all these different elements here. Some of them are going to change, and some of them are not. Okay, so let's look at this first one. Here we got hydrogen. Hydrogen here is +1. Then here it's +1. And over on the right side, it's also +1. Okay, so hydrogen's oxidation number doesn't change at all. So hydrogen's not getting oxidized, it's not getting reduced. So we don't have to worry about that. Nitrogen here is +5 here, and then it's +2 over here. Okay, so we do see a change in oxidation number for nitrogen. It's going down from +5 to +2. So if your oxidation number goes down, it means you are getting reduced. You're gaining electrons. Okay, so nitrogen is being reduced from +5 to +2. Then we got oxygen, it's -2 here. But then on the right side, it's -2 and -2. So nothing changes with oxygen. We don't have to worry about it. Then we already looked at hydrogen, and then we have sulfur, which is -2 here. And then on the right side, it is 0. So this is changing from -2 up to 0. It's becoming less negative, which means that oxidation is taking place. Sulfur here is losing electrons. It is being oxidized from -2 to 0. Okay. Now, I said one of the things that makes this a little bit trickier is that the atoms that are getting oxidized and reduced are part of compounds with other elements. Okay? Now, when we're talking about oxidizing agents and reducing agents and identifying them, people are usually more interested in the compound than the individual atom. Okay, so yeah, so sulfur, this S here, sulfur is what's getting oxidized. But generally, people are more interested in the compound that this sulfur is part of. They're not as interested in just the sulfur itself. Okay? So I'm saying here that sulfur is getting oxidized totally. But we also probably want to say, in problems like this, that really H2S is being oxidized, right? Sulfur is losing electrons, but sulfur is part of H2S. So H2S as a whole is losing electrons. So that's what we're going to say for this oxidizing reducing agent thing. We're going to say that it's H2S that's getting oxidized. It's losing electrons. Nitrogen, this nitrogen atom is definitely getting reduced. It's gaining electrons. But if we're talking about the larger compound that nitrogen is part of, we'll say instead that HNO3 is getting reduced here. The nitrogen is gaining electrons, but the nitrogen is part of HNO3, so the whole thing, the whole HNO3 is gaining electrons. So H2S is getting oxidized, HNO3 is getting reduced because these atoms are part of these compounds. So we can kind of sum this up here with the diagram that I drew. Okay, the S, the sulfur from H2S, is giving electrons to the N in HNO3. So now that we have this information, we can figure out the oxidizing agents and the reducing agents. Okay, so H2S is getting oxidized. It's giving its electrons to HNO3 here, allowing HNO3 to gain those electrons. So it is allowing reduction to take place. So H2S is the reducing agent, and this makes sense with our rules here. H2S is oxidized, and the thing that is oxidized is the reducing agent. And then over here, HNO3 is reduced. It's taking electrons from H2S, which allows H2S to become oxidized. It allows it to lose those electrons. So that means that HNO3 is making oxidation happen. So HNO3 is the oxidizing agent. And we can look at this rule up here, that the thing that is reduced, HNO3 is reduced, the thing that is reduced is the oxidizing agent. Okay? So just remember, when you have an equation like this, where the individual atoms that are getting oxidized or reduced are part of larger compounds, when you're talking about oxidizing agents, reducing agents, you probably want to mention the whole compound instead of just the individual atom. So that's everything that you need to know about oxidizing agents and reducing agents. Okay? The oxidizing agent allows oxidation to take place, so it takes electrons from the atom or the compound that is being oxidized. The oxidizing agent allows oxidation to take place. It itself is reduced and it gains electrons. The reducing agent allows reduction to take place by giving electrons to the thing that is going to be reduced. So it itself is losing electrons. The reducing agent is oxidized. It's also probably useful just to remember this information up here.